Welcome back, Math 098. We are continuing with 6.3 complex fractions. So it's just fractions inside of fractions. But as a reminder, a fraction is a division. So if you really understand, I guess, these types of problems where it's saying 5k over 36m divided by 15k over 9, and you think of the keep, switch, flip, then it makes perfect sense. But I'll quickly explain why this is what we're doing. Because if you want to get rid of a denominator, you can multiply by its reciprocal, and that's only okay if you multiply the numerator by that same reciprocal. So if you look at that, then you could cancel out 15k, you can cancel out the 9, and I just did the keep 5k over 36m alone, switch the division to multiplication, and then flip the denominator. So that might actually help you understand why keep, switch, flip works. So as I'm looking at that, I'm well aware that some people would actually want to multiply straight across, and you could. You'd have 45k over, well, I don't know what 36 times 15 is. If you have a calculator, you can obviously do that. But what I would do instead is look at that and say, oh, well, I have a k on top and bottom. I could cancel those. So I wouldn't even have to mess with this over here. The other thing I would do is actually see that 5 goes into 15. 5 goes into 15 3 times. And because 15 is larger, that 3 goes in the denominator. And the same thought process is 9 goes into 36 4 times. And because 36 is larger than 9, then 4 goes in the denominator. So all I'd have from there is 4 times 3 is 12m. And please, please, please do not forget that you would have a 1 in the numerator, because you need a placeholder. It wouldn't be 0 divided by something. You need a 1 in the numerator to get that answer. So moving on to letter B, really the same thing. These are all fractions, by the way. Just, the pixels don't show up. So hopefully you can see all of them. What you'd want to do is get the denominators to match up first. So maybe I can do 2 steps at once, and hopefully you're okay with that. Just look at the numerator and practice the same skill we did before, where you get the least common denominator is a squared. Well, on the left side, you'd have to multiply a by a to get there, so you'd also have to multiply the numerator by a. So it becomes 5a plus b. And maybe it's helpful if you change it from a fraction to a division sign, and you can do the same work on this one, where you would have b squared as your least common denominator. Well, you'd have to multiply this one by b. So you're left with 5a plus b right there. But just like what I mentioned before, do the keep, switch, flip. So you'd have 5a plus b over a squared, and then flip this one, so the 5a plus b and the b squared on top. And the whole, I hope you're realizing where we're going with this is we could cancel out the 5a plus b's, because we're multiplying, so we can cancel. So you're left with b squared over a squared, a much easier problem than the complex fraction that we started with. So again, feel free to pause and rewatch anything you need to as I do a little bit more complicated problems. But as you can see, they're just, we're doing more of the same thing before you get to the assignment. But I think you guys could probably figure out the assignment because it's just the same skill over and over again. Excuse me. So as I would do this problem, I would just rewrite it. I would actually do 2 things at once. This is how I would do. So the 8x over x minus 4 is fine, but then flip the denominator. Stick the x plus 4 into the numerator, and then the 3 into the denominator, and try to simplify where I can. And really, there's nothing to simplify on this problem. So I think what they were trying to do with this one is getting you to understand that keep, switch, flip. But I hope that you guys get good practice and understand that a fraction is the same thing as division. So you keep the numerator the same, you switch the division to multiplication, and then you flip the denominator. Now letter B, it might be worth your while to rewrite the numerator, because remember x to the -1 power means over x, and same thing with this one. This means x squared y. So if you were trying to rewrite the numerator with just one fraction, the least common denominator is x squared y. So the same thing we've been doing for a while. To get x to x squared, you'd have to multiply by x, and you'd also have to multiply by y. So you have to multiply the top by x and y as well. So that's 3xy. If you look on the right side though, it already has x squared y. So you just have to write the +1 there. So there's nothing to multiply that fraction by. And then I would actually change it to multiplication. And it might be worthwhile to completely change colors. I think I've used this color. I'll just go back to orange. That this is the same as 1 over y squared plus x over y. Well, if I'm changing it to multiplication, first of all, make sure you flip it. But if you're getting the same denominator, you'd have to multiply this by y. So the like denominator is y squared, but notice I'm sticking this into the numerator. And what's like in the denominator would be 1 plus xy. As far as canceling things out though, it would be worthwhile to put in parentheses again, because the only thing you can cancel out is one of these y's, because remember y squared is y times y. Up here we had a 3xy, and down here we have a 1xy, so those cannot be canceled. The best thing you can do is rewrite as 1 y quantity 3xy plus 1 over x squared 1 plus xy. If you want to do the commutative property, that's fine, but there's nothing else to do there. So how is that different than this last one? And again, it might be worthwhile to rewrite it. Because of the parentheses, it's actually 1 over 3x minus 2, maybe over 1. And this one doesn't have a parenthesis, so it is 5 over x plus 2, 2 over 1. So how can we do this? Again, I'm going to do the keep, switch, flip at the same time as getting the same denominator. So the like denominator would be 3x. I'd have to multiply this by 3x. So I have to multiply the top by 3x. So that becomes 1 minus 6x times, because I'm switching from division to multiplication. So while I'm getting the same denominator as x on this problem, I'd have to multiply, like the same denominator as x, but I have to put it into the numerator because I have to flip it. And the denominator is 5 plus 2x. So as I put in some parentheses to help myself out, the only thing that cancels is this x. So there's nothing else that's like. So what do I have? 1 minus 6x over 3 times the quantity of 5 plus 2x. And again, if you want to do the commutative property like 2x plus 5, that's fine. You don't have to. So as long as you simplify correctly, you will get full credit. Notice that your answer might not match the back of the book, but you could still be correct. As I'm looking at this, I'm realizing how fast I went through all the problems, because this is only at 9 minutes. So if you feel like we need to set up a Google Meet, talk about these problems in class, then by all means we can. And write down your questions, because you might forget your questions between now and when you have an opportunity to ask me. So, but I'm done explaining. So